Um, I'm Martijn Walraven. I live here in Amsterdam, but I work for Meteor Development Group. And as I was preparing for this talk, I realized that maybe a better title would have been um, Building Apollo. As you will hear, Apollo is quite an ambitious undertaking. It's our most recent project. It's something we've only just started. The first pieces are coming together, but it's definitely a long-term project. So if there's anything um, you're um, you're getting from this talk, I think the vision and hopefully enthusiasm and maybe even involvement is probably the most important outcome. Um, so before I introduce Apollo, I think it's important to understand where we're coming from, and that is Meteor. And I really have no idea how many of you know Meteor. Uh, Quite a few people. How many have actually used Meteor? Uh, Also, quite a few people. That's interesting. Um, Meteor is first of all an open source project. It was first publicly released in 2012. It's quite a popular project. It generated a lot of interest when it first came out. It's kept growing since. For instance, one of the measurements is the number of GitHub stars, currently at sort of over 33,000, more than Rails, for instance. Something we're still proud of. Um, there's also a serious company behind it, Meteor Development Group, venture back, still quite a bit of money in the bank. It's will be around for a while, and but actually, what I like most about Meteor is the amazing community. Um, there are sort of almost 300 meetups around the world, um, literally around the world, places I probably don't even know the name of. Sometimes we get pictures sent from hackathons in Nepal, Meteor hackathons. It's really amazing. So a lot of people are using Meteor, talking about Meteor, but why? What is Meteor? And in order to understand Meteor, it's important to understand sort of when it was developed. 2012, as I said, was when it was first publicly released. Um, the world was really a different place back then. A lot of what we now take for granted in the JavaScript ecosystem didn't really exist. Server-side JavaScript was just getting started. Um, there, um, there was no Webpack, no Browserify. Their npm didn't really have support for client-side packages. The view layers like Angular or React weren't there. So the Meteor founders had to build sort of in order to make good on their vision of an integrated application platform. They had to develop a lot of the pieces from scratch. They developed their own build tools, their own packaging system, their own view layer, Blaze, um, and now that a lot of these pieces actually have really good sort of alternatives in the JavaScript ecosystem, Meteor is starting to move more and more in the direction of sort of mainstream JavaScript. So, for instance, we support React and Angular in addition to Blaze, our own view layer technology, and in fact, it's something we recommend people use. Um, we also support NPM in addition to our own packaging server, and we're transitioning away from our own packaging system. So what will be left of Meteor when you take away these pieces and sort of transition into standard JavaScript? Well, to me, sort of the most exciting part of Meteor has always been the data stack. Um, This is what got people really excited about Meteor, even from sort of the first screencast. And to give you just a quick, really high-level overview of what that data stack does, what's central to it is the idea of isomorphic JavaScript code, but also isomorphic data access. So you can literally run the same data access code and data mutation code on the client and on the server. And the API it uses is the Mongo API. So on the server, you connect to an actual MongoDB. On the client, there is a sort of client-side cache, mini Mongo, but they support the same API. And the way you modify your data, access your data is through this API on both the client and the server. Reactivity is supported on both the client and the server, and actually throughout the stack. So modifications in your server-side MongoDB will get propagated to your client mini Mongo, and through the client-side reactivity layer that updates your UI. So a lot of these concepts are more mainstream now, but when Meteor first came out, this was really revolutionary. And I think we're only now starting to get at a point where some other technologies are getting at this level of sort of integration and reactivity. So how does Meteor differ from, let's say, a data loading technology like REST? Some of the things that people like about Meteor is that it's not really, you don't really care as much about sort of loading data as an operation, but you specify your data needs. You specify in the form of subscriptions what data your application needs at what point in time. And then sort of the infrastructure shared between client and server is responsible for getting that data to your client. It's not merely a list of sort of individual endpoints as you would get with REST, but you have sort of semantic data, data containing collections with a certain identity, and you're not sending independent requests, but the server actually knows what data you have in your client cache and makes sure only to send sort of the exact data that you need, the difference between what you need and what you currently have. So Apollo, one way of describing Apollo is as sort of the next generation data stack or a natural evolution of the Meteor data stack. That's not how we really see it though. And the reason for that is that Apollo is a project that is completely independent of Meteor. We think the sort of the vision behind the Meteor data stack is something that should not be limited to the Meteor ecosystem. So we're really hoping with Apollo to create a data stack that is useful, well, very ambitious, but sort of with any backend, any client, and any language. So within the JavaScript ecosystem, we're focusing on React and Angular, but there will also be native clients, there will be different server-side solutions, but Apollo is not something that we're doing completely ourselves. It's actually our attempt to really participate in the GraphQL ecosystem, and I'll say a little more about GraphQL later on. But first, sort of the why question. Why would you actually want to use a system like this? And the issue that underlies this is something that I think most developers are familiar with, and that you might call application data management. Applications have data needs. That data, in many real-world scenarios, is spread out over different systems. Even with sort of a simple REST API. In theory, REST is a really nice, normalized data access technology. You have individual endpoints for your different resource types. But in practice, what you really need, especially when you start thinking about mobile apps, is a very specific set of data for every part of your app. You don't want to load too much. You don't want to load too little. You certainly don't want to make multiple round trips to the server in order to load your data. So what happens is that you end up with these, what you might call feature APIs. There's a really tight coupling between parts of your app and endpoints on your server. That means application development now spans teams in many cases. So as, let's say, an iOS developer, if you need certain data, you need to ask your backend developers to add that to the database schema and to the endpoint. REST endpoints, in general, specify what data they deliver to clients, and clients simply call the endpoints. The situation becomes even harder when you consider sort of multiple client types, like an iOS app, an Android app, a browser app, maybe apps for different audiences. So you basically end up with sort of a back end for front end. So you have very specific routes, very specific endpoints for your specific apps and part of your apps. And then, of course, especially in enterprise environments, many apps connect to multiple backends. You have the idea of microservices, and that further complicates the situation. So what would be an ideal situation is to find a way to decouple clients and services. And this is why we were so excited with the announcement of GraphQL. In Meteor, we've tried sort of to deal with these situations with our MongoDB layer, but that often meant sort of duplicating information that was already in other systems in MongoDB databases. Was something that really restricted use of Meteor, the fact that we only supported MongoDB. And GraphQL is a really nice sort of application level query language that is not tied to a specific database technology and that very naturally supports multiple backends. I'm going to assume most of you have at least heard of GraphQL. So some of the nice properties to solve the problems I talked about before is that it's a nested query language. So it really lends itself well to composing queries that result out of sort of the data needs of the different components in your app. Your UI components can each specify their own dependencies. Those get sort of put together and sent to the server as a single query. There's a very natural mapping between the shape of your query or your query fragment and the data you actually get. So there isn't much sort of processing you need to do on the client in order to display it, which fits really well with technologies like view layer technologies like React, where we don't have complicated model layers in general. It's just JSON. And on the server side, there's a really nice sort of resolve system that naturally lends itself to aggregating data from different backends. So Apollo is the idea that a sort of middleware layer that connects individual clients and client types to different backends would be a really nice solution for these types of problems. And GraphQL is something that makes constructing such middleware really feasible, and we think much better than many of the existing attempts at solving these problems. So what would happen, sort of to make this a little more concrete, on a client if you were requesting data through GraphQL from the Apollo server? Well, you have your data requirements, specified as GraphQL. And then what you really want is a smart client, similar to the mini Mongo client cache in Meteor. What you want is a sort of normalized cache on the client, so no duplication of data. That makes it easy to diff queries, make sure that you don't request data that you already have, and then you only send the minimized query to the server. The backend server then aggregates the results, you return them to the client updates its store, and then you deliver the result to the UI. That's sort of the really high-level overview. Mutations can use optimistic UI. There are a lot of variations on this basic schema. But let's talk a bit about sort of the pieces that are needed to make true on this vision and how we're going about building this. So, as I said, like we really want to do this together with the rest of the GraphQL ecosystem. Meteor has been sometimes a little isolated. It was really, a lot of the developments were dependent on work by us, core developers at MDG. We hope that by working with the rest of the community from the start and building solutions that are not only useful within sort of the vision we have in mind, but that other people can use to satisfy their needs, will help us build something that is more sustainable and that will grow more naturally. So obviously, the GraphQL tool Facebook released, Facebook open sourced, are central to this. So GraphQL.js, the JavaScript implementation, data loader, all kinds of different tools. Relay is especially interesting here. I'll say a little about this, a little more about this later, but Relay, of course, is a huge inspiration for what we're building. There are also other implementations in other languages, other environments, Graphene in Python, Sangria in Scala. So we feel there's a lot of movement throughout the ecosystem. And we're hoping that by working together, we can really build something that is both a better data stack for Meteor and also something that really makes true on sort of the vision we have in mind for software development in general. So the first step is really fairly concrete. This is something that we really have to get sort of down to earth to do this. GraphQL is in its early days. A lot of the tools are usable, but not very developer friendly. A lot of the patterns still have to be discovered. Abstractions still have to be built on top of sort of the core primitives. So our first goal is to build the tools to really improve the GraphQL developer experience and discover how people are using GraphQL or how we should be using GraphQL. And we actually have a Medium blog called Building Apollo, where we sort of document our journey. And the first pieces we're building, so these are really, especially in the server case, one way of describing this is as sort of a toolkit. So we're really trying to fill the gaps in the developer experience. For instance, in the current GraphQL tools, we have a way of constructing a GraphQL server from the GraphQL shorthand and independent resolvers, while in sort of the standard way of constructing servers in GraphQL.js mixes sort of both declaratively creating your schema and your resolver functions. We think separating those two will lead to a more readable and maintainable code. So that's just one pattern that we thought was useful, and we're hoping other people will also find useful. We've added ways of mocking servers. So this is sort of a toolkit. The other piece is Apollo Client, and that is more of a sort of solution that people can use as is. So it's a Relay-like client, but it's built on Redux. One of the things we felt was missing in Relay was sort of the understandability, discoverability that Redux gives you. And we also recognize that many people have existing apps on top of Redux, that they use Redux for other parts of your state that may not come from a GraphQL server. And it's just this very natural way of building a data layer in this ecosystem. So we hope to support most Relay features, pagination, optimistic UI, reactivity. This is work in progress. We're hoping to release a first alpha this week. And that'll have sort of the basics. It actually does, it fetches query and stores them in a normalized object store. It does query diffing, so it only fetches queries when the information is not in the store. And sort of the vision behind Apollo Client and what we think makes it different from, let's say, Relay, is that we really want to focus on debugging, transparency, simplicity. That's something that Redux and the Redux Dev tools give you. And our experience with Relay was that when things broke down, we had no idea where to look. So I only have a couple of minutes. So I don't think the code examples are the most exciting part here. We're using observables as our interface, which works really nice with Angular. But for Relay, we're using a more natural sort of Redux connector. You can either let Apollo create your Redux store or use your existing store and combine the reducers. And then you use a high-level component, a container, to connect your queries to your to the props of your component. Reactivity, full stack reactivity is really something that we think should come after the basics are in place, but we have some interesting ideas about it. There's a blog post about it as well. But the most important message is, if you think this sounds interesting, if this is something you think would be useful, please get involved, which you can do in many different forms. Read our blog posts, comment, open issues, maybe even contribute. We have a few outside contributors already. And also, as a company, we're actually hiring. We're looking for someone who is sort of intimately familiar with the React ecosystem. So if you feel this is something that might be a fit for you, we have remote positions as well. So talk to me or send me a DM on Twitter. And I think that was what I wanted to say.